G'day coppers, welcome back to the bush. In this episode of Lockyup's Full Driving, we're looking at porting the heads of the Thumper Max I. You've already seen the electrical mods, you've already seen the outlet plumbing mods, and now it's time for the heads, both inlet and exhaust. We'll be doing an RPM test and an all-important inflation test. First up though, let's see where we're starting off from. And here's the dimensions of the standard ports in the Thumper Max head. So you got 2 inlet ports per head at around about 6.75mm across each. And the exhaust ports, 5.3mm across each, and of course there's 2 of those. That gives us an inlet area of around about 72mm squared, an exhaust area of about 44mm squared. Now your ideal inlet to exhaust ratio is 1.2 to 1.5 to 1. The reason for that is when air is coming into the compressor, it's only relying on atmospheric pressure and the vacuum within the cylinder from that piston going down. Whereas the exhaust, well, that's relying on the compression in the cylinder forcing that air out. So you don't need nearly as much area to get that exhaust out as you do to get that air into that cylinder. Now the inlet to exhaust ratio for the Thumper Max head, 1.622 to 1. So a little bit over the odds, but not too bad. Now let's have a look at the exhaust ports in the Thumper Max head. These are the 2 inlet ports and these are the 2 exhaust ports in the one head. So it's got 2 heads per machine, obviously. This is the reed valve assembly on the left hand side and I've removed it on the right hand side. You can see an issue. That's the O-ring that surrounds the port. We can only open it up so much. So we've got 5.3mm standard exhaust port in that Thumper Max head, and the ID from here to here is only 7.5mm for that O-ring, and we need some supporting material behind it, otherwise it's going to collapse and we won't have a seal there any longer. So I thought, well, I'm happy to go to 6mm. So that's as far as I'm willing to go, and that's going to be an issue to maintain that inlet to exhaust ratio in the Thumper Max head. That'll limit exactly how far we can go with the inlet ports. Now we know the exhaust port area, let's have a look at our inlet port options. So 6.75mm standard, what happens if we drilled it to 7mm? Well, that'd get us a little bit short on that inlet to exhaust ratio of nearly about 1.4 to 1. What about a 7.5mm hole? 1.56 to 1, so it's getting a lot better, but it's still a little short of standard. What about the 8mm? 1.78 to 1. So I've decided that's it, I'm drilling them out to 8mm. Now let's look at how much we can chamfer those ports. Now I'm going to use a 45-degree chamfering tool, which is very common, and I've got an 8mm ID hole. I have a limitation though. The limitation is the plate itself is only 6.5mm thick, and I wanted to leave a little bit of the original hole left, so I've decided to leave 1mm of that hole left. Okay, so how deep can I go? Well, it works out I can go to an OD of 19mm. So the outside of the chamfer at the head surface will be 19mm. So I need a chamfering tool which is in excess of 19mm in diameter. And I happen to find one that's 20.5, so that'll work just fine. And here's an overall view, and this is a scale from the cylinder side of the head. And you can see my chamfer is going to cut a little bit into that O-ring groove there, which isn't fantastic, but as long as I compromise it as little as possible, I think I should be okay. Now the next possible point of restriction I wanted to look at was the head chamber inlet, and here it is here. This is located just below those air filters. Now our 2 now 8mm diameter inlet ports have a total inlet area of just over 100mm squared. When I measured this up in the computer program, it gave it to me at 142mm squared, so in excess. In fact, it's nearly 42% larger than the inlet port area, so no problems with a standard head chamber inlet. Now let's look at how big we can go with chamfering those exhaust ports using that 45-degree chamfering tool. 6mm hole in the middle there, don't forget that, and we need to leave at least 1mm of the original hole for some structural integrity. When we worked it out, that gave us a total OD at the top of that chamfer of 17mm. But how will that work in the head? How far will we compromise that outer seal? And here's from the outlet side, and as you can see there's a fair bit of overlap in between these 2 chamfers, and not only have we fully compromised the ID of that O-ring seal for that cylinder, we've given the outside a little bit of a touch up as well. Another consideration is this O-ring seal here, and don't forget if we go too deep we'll be compromising that seal as well, so we want to stay right away from that. And now we've got a bit of a plan of how we're moving forward. Let's go to the pedestal drill and start making metal chips. Now the first process was to drill out those exhaust ports from that standard 5.3mm to 6mm. I was a little concerned with this one because the as-cast ports aren't exactly concentric with those O-rings. Next up was drilling out those inlets from 6.75mm as cast to that 8mm drill size. Now to countersink, I'm using a 20.5mm 45 degree high speed steel countersink, and I'm running it pretty slowly, as you can see in the video here. And now I've scribed on the head 19mm lines so I don't go over, but I'm going to measure it with a vernier, as you can see now. Okay, on with the exhaust. Now there's a couple of protrusions in the top side of the head, so I had to cut a couple of recesses in a piece of wood so I could get it laying nice and flat. Next up, for the countersinking. My original intention was to drag them out to 17mm at the top of that countersink there, but well, it was starting to cut into the O-ring recess, and I knew that would happen, but I lost a bit of my nerve and only kept going until I reached the top of that recess for that O-ring seal for the cylinder, and that was it. And the last thing to do, any of the holes that hadn't been countersunk, well, I'd have to deburr, and that means just knocking off the top edge with our countersink tool. And now you've seen how we've gotten to this point, it's time for the testing. First up, the comparison RPM test. Now guys, if you're enjoying this content so far, don't forget to subscribe to the channel and ring that bell icon so you don't miss out on our future content. Now if you want early access, ad-free, consider becoming a patron on Patreon. There's a link down in the doobly-doo. In fact, what I'm thinking is, if this video gets 500 likes, I'm going to try running this thing on 24 volts. It's either going to run extremely well or it's going to let the magic smoke out. One of the two. Anyway, so click that thumbs up. Let's get on with the video. So let's check out exactly how fast the Thumper Max is now turning with those ported heads. What I've got here is a current clamp, and what that's going to do is measure the amount of current that this motor is taking. Now, when the piston's going up the bore, it takes more current to do that because it's compressing air than going down the bore. Now we've got two pistons here, so when we measure in between three peaks, so this one's going up, we measure the peak there, this one's going up, we ignore that one, and then back to this one again, going up again. It's a two-stroke engine effectively, so in between those three peaks, we'll be able to see how far that is in time and then work out the RPMs we're doing. Alright, so let's turn it on and then we'll freeze frame it. Okay, now let's head over to the oscilloscope and check it out. So all I have to do is get the cursor, type cross, and measure in between this peak here and this peak here, in between those three peaks here, and that's 5.16 milliseconds. Okay, let's move over to Excel and check it out. So 5.16 milliseconds, and that gives us an RPM of about 11,627, or nearly 28 revs per minute. Now let's compare that with the previous results. And here's the comparison. Standard, well, first up, standard did 11,112 RPM. With the outlet manifold from the last video, 11,858. And finally ported, well, that came in at 11,628. So not a lot of difference between the outlet manifold and ported. Let's run through the testing setup. So I've got a 5-volt regulated power supply here. That's running down to that pressure transducer down there. That puts out a variable voltage depending on how much pressure's in the tyre. As you can see by the gauge up at the top there, 18 PSI at the moment. That's being read by the mushy meter. Also being read by the mushy meter here is the current clamp. So we're going to go from 18 PSI to 38 PSI in a 35-inch tyre, a 315 75 16. And of course we control the mushy meter with the phone here. So we'll zero out that current clamp. There we go. We'll start the logging. Logging started. Okay, 18 to 38 PSI, off we go. And there we go, we're back up to 38 PSI. Let's compare the results. Now let's check out the result of the ported head in the Thumper Max II. And as you can see, the pressure's along the bottom there and the current's along the top. Seemed to suck down about 90 amps consistently and did 18 to 38 PSI in that 315 75 16 or 35-inch tyre in 52 seconds. Now for a final test, I keep hearing how these air filters keep blocking the air and you need to open them up. So if it doesn't affect the results now, with ported, the electrical's fixed and the plumbing fixed up, it's never going to affect it. So we're back down to 18 PSI. I'll zero out the current clamp. There we go. Start the logging. We're at 18 PSI and off we go to 38 PSI with no air filters. And there we go, we're back up to 38 psi. Let's compare the results, filters versus no filters. And don't forget, if you want to see me running this thing on 24 volts, give it a like. So here's a standard run with filters, 52 seconds and about 90 amps from go to woe, from 18 to 38 psi in that 35-inch tyre. Let's have a look without filters. Again, almost identical, 52 seconds and about 90 amps right through. Even with a modified Thumper Max, there is zero benefit to modifying your air cleaners. That's it, done and dusted. I'm glad to knock that one on the head. Now let's have a look at the results. First up, the baseline. Now this is a dead standard compressor straight out the box, pumping up a 315 by 75 16-inch tyre, 35-inch tyre, 113 seconds standard. What about when we completed the electrical mods? Well, that substantially decreased it down to 44 seconds. And again, the only additional modification I did was to remove the Schrader valve, and that remained consistent for the rest of the testing. What about the plumbing? Well, when we did the external plumbing, it actually dropped it off a little bit, down to 47 seconds, which isn't great, but I was hoping that was providing the infrastructure that would be required to flow the amount of air once we did the porting. Once we did the porting, yep, 52 seconds, even worse. That's not great. So what's our takeaway? Well, every modification we've done, bar the electricals, has actually ended up in worse performance. Both the porting of the heads and the outlet manifold, which is a bit of a bugger because that was a bit of work. Anyway, no worries. I think I know what the culprit might be. I think it's the valve timing. I think because we've changed the area of the port, what's actually happened is it's changed the timing of the valves. Now, if you want to see me tackle that, it's going to be a bit of a doozy. Leave a comment down in the comment section. Anyway, guys, now if you like this video, give it a thumbs up. And if you didn't, by all means, give it a thumbs down. Not once, not thrice, but twice. Thanks, guys. We'll see you in the next one.